This is a Biology 10 review video for codominance as it relates to blood typing. Codominance has three alleles for blood type, A and B, which are codominant, and O, which is recessive. Now, A, B, and O refer to the type of blood you have. If you are type A, then you have A antigens on your blood. We don't need to be concerned exactly what an antigen is, but it is something that your body attacks if it is foreign. If you have blood type A, it's not foreign to you, and your body won't attack it. If you are a type B blood, then you have B antigens on your body. Type AB isn't a third antigen, but simply having both antigens on your blood, both A and B. O refers to a lack of any antigen whatsoever, and O blood type has no antigens. The blood cells are clean. Now in genetics, if you're blood type A, you actually don't know if you're homozygous for A or if you're recessive. If you're homozygous for A, that means you have both alleles for type A and you're homozygous A. If you have the recessive O gene, then you're still type A because O is simply the lack of an antigen. But you don't know which type you actually are. If you're type B, the same thing. That means you have the B antigen, or you might have B as well as O, but in both cases your blood will look the same. It will have the B antigen. There is only one genotype for type AB, and that is having both alleles. Everybody has to have two. That's why all of these types are paired, because you get one from your mom and one from your dad. Thus, you have two copies of every gene. And for the last one, type O means that you have both recessive O's. So both of your genes lack an antigen, and you have type O. Now, what does this mean in terms of blood donation? Well, it means that if you have type A blood here, and you are given type B, I am type B. When you're given type B, now your body is exposed to the B antigen for the first time. And your immune cells will attack it, the blood will clot, your kidneys will fail trying to get rid of all this clotting blood, and you will die. It's very serious to be given the wrong blood type. If you are type B and you're given type A, the same thing. Your body will attack the A antigens, the blood will clot, and you will die. Pretend for a moment, however, that you are type AB. You were given type B blood. Well, that's perfectly fine, because your body knows the B antigen, and so it recognizes this blood as self. Same as if you're given type A. If type AB is given type A, then that's perfectly fine. This is why type AB is often known as a universal acceptor. It can take all types of blood. Now, type O is the universal donor. Without any antigens on the outside, you can give type O to AB, to type B, and to type A. There's no antigens to interfere with the process. However, if you're type O and you receive any other type of blood, AB, B, or A, your body will attack those antigens, the blood will clot in your bloodstream, your kidneys will fail, and you will die. So, in terms of pure selfishness, you'd rather be type AB. However, in terms of altruism, you'd rather be type O in order to be able to give blood to everybody. So type A and B are codominant, because if you have them both, they're both expressed. But type O is recessive to the A and B. Just to review, your body makes antibodies against foreign antigens. These are normally on things like bacteria and viri. However, they can also be on foreign blood. And if you're a type A and you're given type B blood, the B antigens are attacked, the blood clots, and the person dies. Now, how does this relate to Punnett squares and genetics? Well, consider the following case. A child is born with blood type A. The mother is blood type AB. The father is blood type B. Are these likely biological parents? Use the Punnett squares to determine this for yourself, then unpause and discover the answer. Now, the mother can only be of one blood type. Since she is type AB, then she can only have A and B. and that one's easy to set up. However, the father is type B. That leads to two possibilities. He is either homozygous for B or heterozygous for B. The mother is type AB, which leads to either AB and AB. It's the same, there's no change, but the father is blood type B. We don't know if the father is homozygous for type B or heterozygous for type B, so we need to do a Punnett square for each in order to determine this. Now it says in the question the child is born with blood type A. There is a possible blood type A here. There is none if the father is type B homozygous, but there is one possibility if the father is type A heterozygous. And so, although these biological parents may not be likely, there's a 1 out of 8 chance of all these possibilities, we can say that it is consistent. There is nothing that we can do to rule out the father as a biological contributor. And now, a second example. Example 2, the father is type AB, mum is heterozygous A, child is type O. Are there any problems? Try the Punnett squares and give your answer. Unpause when you're ready. Okay, in this example, the father is type AB, and the mum is heterozygous A, which means that she has both the A and the O allele. The children will then be as follows. Of these 4 possibilities, notice we didn't need the other Punnett square because both of the parents were fixed. None of these possibilities are type O with the child, so this is inconsistent with the data that were given for the blood types of the parents. Either the blood types of the parents is incorrect, or one or more of them is not the parent. So we can say yes, there is definitely a problem. Now for the last example question. On the Larry Show, which of these 4 guys is the father? Possibilities are Dave, blood type A, John, blood type B, Tom, blood type AB, and Rex, who is blood type O. Betty Ann Ray, the mother, is blood type B homozygous. The child is type AB. Who could be the father? Who cannot be the father? Use as many Punnett squares as you need. When you are ready, unpause the video for the answer. The blood type for the mum is homozygous B, so that can be set up for every Punnett square. The first possible father is Dave, who's blood type A. Now that could either be homozygous A or heterozygous A. Having set up homozygous A and heterozygous A for Dave, the possible children are, now with Dave, with the 2 possibilities of blood type, we can say, well, 2 out of 4 here and 4 out of 4 here could be the child, which is type AB. So Dave is definitely a possible winner. Dave is consistent with being the father. Now let's consider John, type B. Now with John, if John is homozygous B, there is no possibilities of an AB child. And if John is heterozygous B, there is also no possibilities of an AB child. So John is consistently ruled out as being the father. Now we have 2 more possibilities, Tom with AB and Rex with O. Now with Tom, who's type AB, we have 50% chance of a type AB and a 50% chance of a type B. And so Tom is also a possibility of a father. So Tom and Dave are definitely winners. Rex can only, with this particular mum, have a type B child. BO means only the B antigen will be expressed, so there is no chance of a type AB. So Rex is also ruled out. And that is the end of the review for codominance and blood typing.